Hello, hello. Howdy. Howdy, party floor. I'm loving the beer. I'm loving the beer in the middle of a conference. How very Yorkshire. That's fantastic. I am a fellow Yorkshireman, but my home is now Manchester, well, Salford, as the BBC insists on calling it, the Media City UK. It's a very shiny place where about a third of our online development is. I'm head of architecture for various bits that the BBC does. I've got a buzzword, nanoservices, to talk about. Nanoservices, can't even say it. But it's really all about kind of serverless and interesting ways in which you can use that. So the BBC, as I'm sure you know, is pretty darn big. We are the third most popular website in the UK after anyone, I guess? Facebook? Google. Spot on, yeah, pretty obvious, right? We have tens of millions of users a day. Our sign-in system, the annoying sign-in system, you have to sign in to watch iPlayer, gets 26 million people regularly signing in. You know, fairly big numbers. We can easily have millions of people watching video at once. It's a pretty big scale operation. And to be honest, scaling out the same stuff to everyone is kind of straightforward nowadays, right? Lots of caching, CDNs, load balancing, auto-scaling on the cloud. It's all fairly standard stuff. So I wasn't going to talk about that. That's all kind of boring. I was going to talk about some kind of other interesting ways in which you scale. Scale when you want to be personalized. I mean, at the moment, the BBC website, you know, isn't that personalized. Everyone gets the same news. There's a bit on the iPlayer homepage to kind of recommend stuff. But, you know, like for me, the new royal baby being born, that is the least interesting news of the year to me. But clearly to Daily Mail readers, it is the most important thing of all time, right? Different people have different things. So becoming a bit more, I mean, there's a big debate about whether or not, you know, it's right for news to be that personalized. You can end up in, you know, oh, let's not go there. But in general, the world is moving towards wanting websites that are not the same for everyone, right? So that is a huge scaling challenge. And also, the BBC's competitors are no longer ITV, Sky. They are YouTube, Netflix, Facebook, right? They are the other places in which you get your news, your entertainment, and so on. And so they are massive, and they don't mind losing a few $1 billion to invent something, right? That is unfair. And so we're going to have to do something really clever if we are to somehow compete and offer that, given that we are a public service, we don't have infinite money, we are spending public money, and so on. We need to be super clever to scaling just people and scaling your ideas so that you can do more with. We've got a few hundred developers. We're very lucky, but it's, you know, it needs to be a truly phenomenal engineering effort to kind of keep up with that competition. That's the challenge we have. First up, this is awesome. Is there a Leeds-Manchester rivalry? I really think there should be more of one. Right? Friendly competition. Right? I'm not sure there is a tech conference this good in Manchester, so I'm going to go back and try and organize one. Right? I think we should try and get some competition going. I tried to Google whether there was any, and all there was a proposal for a sign like this on the M62. Which we really should do. How fantastic would that be? I mean, if you don't know the M62, it gets rather bleak over the top. So to have that welcome you as you kind of come down the other side of the Pennines would be just brilliant. And then, of course, someone had photoshopped up what the other side should look like, though they seem to have forgotten to change the URL. Never mind. But what a great idea. And kind of echoing some of the great stuff that Sarah was mentioning before, a lot of this is down, well, maybe not all this, that's different, but commodity. The world is moving so quickly, the technology world is moving so quickly, that things are becoming commodity very, very quickly. And if we don't embrace that, we're just going to stay behind reinventing stuff that has been made already, and we're wasting our time not doing the true different stuff. So take, for example, smartphone. Hands up if you've not got a smartphone. No one. Is that the most ridiculous question ever asked to a tech conference? Yeah. Of course it is. Yeah, it's just, but what you have in your pocket is just, you know, it's better than the laptops were 5 years ago. The modern ones have AI chips in them. They have 1 million apps in the App Store. It's all blatantly obvious now, isn't it? But it's truly phenomenal when you stand back and think about it. Just how few years it's been since we had that. And now it's causing all kinds of wonderful stuff to happen, isn't it? Like we're all massively addicted and teenagers are in trouble and this kind of stuff, right? But there is the bad side to every story, but the phenomenal effect of that stuff is just, you can carry it on lots of things, right? Machine learning, we mentioned a few times today. I'm going to disagree with the AWS chap, Ian. It is flipping hard to do this, unless you take an off-the-shelf one, in which case it's really easy. And because it's now become so easy that you know, you can go off and recognize it. And did you see that story? That this is about one of the, I can't remember which city it was in China, but they've got so many thousand cameras now all done to facial recognition that they know precisely where everyone is at any moment. Utterly petrifying, right? But to your point, Anne, about some of the ethical dilemmas we face. And the fact that everything is now connected, so you can have a black box in your room tell you that there's going to be some bad weather ahead because it knows where you're going and all this kind of thing, right? The fact that you can now get doors that unlock themselves as you're coming home or to the delivery man, right? Kind of petrifying, isn't it? But it's also amazing if you ignore the ethical challenges. It's amazing what we now take for granted that only a few years ago we didn't. What's the bad news story on this one? Oh yes, Cambridge Analytica, the death of democracy. Let's assume for now that we're all doing ethically great things, right? Let's assume that we're all using this drive, all of these wonderful things that even 5 years ago you weren't really available to. They're now all available to us quite easily. Is all just due to that massive drive of things becoming commodity. And the real trick is to make sure that you don't resist that you keep embracing that change. You're obviously going to be a little bit careful which bandwagon you jump on and go off on. But it is moving so quickly that unless we keep reinventing things, we are just, your competitors are going to instead, and you're just going to be left behind. Ian showed this morning. Do you remember this graph of number of releases AWS are making every year? I'm not an Amazon sales guy. We do use Amazon quite a lot, but I know that they are quite good at banging their own drum. Every time a product person sneezes, they launch it. So this is a little bit of it, but you can still get the point. It's almost exponential in scale, right? The amount of stuff they do, because there's a $1.4 trillion potential cloud market that they've realized, and so Google, Microsoft, you can see why they've all changed. You can see why Google has now become a cloud company more than a search company. It is phenomenal, the market they've got and what they're doing to get there. Breaking Moore's law in a way, if you know that. So if you don't use this stuff, others will and will be better than you, and you will end up on the old stack, right? You should expect that anything you build will need to be rebuilt within 3 years, which is quite a hard thing to pick up on. Particularly if you're used to the old style one where you're building a data center and you've got a 15-year lease on it or something like that, right? That's got to go because this stuff is just moving so quickly. This is the classic one for developers, right? Kind of the different ones. And it doesn't mean, of course, that you can't use this stuff. There are some really good reasons to use assembler or C if you need to do some really low-level stuff, if performance is critical. But it's 1% stuff, right? It's unlikely you're doing that very much. And, we can debate kind of a bit down there, and maybe Ruby's about out of date now, which will be, what is it, Kotlin or Go or whatever your favorite kind of modern one is, right? But it's true, in Java, if you're writing a bank, Jason, Java is a great choice. But for most of us, why? When there are much richer, more higher level languages, that is the argument. Most of the time, you're going to be over there. And it is really hard. I think it's great now, compared to earlier in my career, the number of engineers I meet who go, well, I'm a Java developer, or whatever the language is. I can't possibly change another language. That seems to be happening less and less now because people realize it's about the right tool for the job. And so it's got to be about that flexibility, embracing new tech, right? This is 5 years old. I only just discovered it a few weeks ago. Have you seen it before? Thomas Thwaites did this project. He tried to make his own toaster. So we went out. We started off by going out and buying the cheapest toaster we could find, a $3.99 one from Argos, and then tried to make his own using nothing that had already been made by man. So he went and mined the copper, and he worked out how to make plastic and all this kind of thing. And it cost him over $1,000, and he came up with that. And he did actually plug it in. And for 5 seconds, apparently, it did toast before then catching fire. So completely ridiculous. But the idea, just bought a new house or a new kitchen. Shall I make my own toaster? I mean, what a ridiculous question that is, right? But we have a habit in software engineering of reinventing the wheel, right? It's very comfortable. We know how to do that. And are we sometimes making our own toaster when it is completely off the shelf? The classic one, as we've already discussed today, is the world of Let's have our own data center. No, don't do that. I mean, there are some reasons why you need to have servers nearby. If, for example, if latency is extremely important, so you've got some very proprietary technology, you will do that. In the world of broadcasting at the BBC, sometimes you need the server to be next to the studio because the camera talks to it and it needs to be there with no latency. So you always have those cases, but it's pretty rare, and even then you probably can virtualize it. Then, of course, you've got the cloud that takes the virtualized machines and puts them somewhere else. Then you've got containers, as we were hearing from Sarah earlier. And of course, the next one from that is serverless. Why would you go there? It's the same principle, that idea that it is now commodity, a lot of what this is happening. And it's a point here where you're installing software. You're having to configure a box, worried about auto-scaling, load balancing. All this is really quite boring stuff. If you've you've been on the Amazon course, whatever, and you're doing all these things, it's oh yes, it's great. I can set up my load balancer, and I can, wow, auto-scaling happens. That's brilliant. It's a great way to make more money if you're a cloud provider, isn't it? But really, you don't want to do any of that. You just want to have your logic, right? You've got your rules. That's really what you're doing. It's going, when something happens, when a user presses a button or whatever, some logic needs to happen. And you want to write that code that goes, this is what you should do. But in this perfect serverless world, you then just give that code over and go, magic happens. Of course, there are servers running it underneath, but you don't care about them in the serverless world. We mentioned Simon Wardley earlier, and he's got a very interesting. So if you don't know Simon Wardley, he does a lot on mapping out a kind of technology business and looking about how to drive things towards commodity, particularly when it's further away from kind of your market differentiator. And he points out this could fundamentally change how we build business around technology. You thought DevOps was big, but that was chicken feed compared to this. This is a world when everything is serverless. Of course, some bits we treat as serverless today, email, Gmail, or Office 365, or whatever. There must be some servers somewhere, but you don't care, right? It's just magic and it happens. It's that concept applied to pretty much all of our technology. Think of all the stuff that you've written that your organization does in a serverless world. That's quite a phenomenal change, right? But if you get it right, and you've managed to abstract away loads of scaling problems and loads of unnecessary time configuring things, working out how things scale and so on. Okay. Serverless typically means the three serverless function services provided by the three big cloud providers, Lambda, Azure Functions, and Google Cloud Functions, which are all kind of the same thing. And if you don't know them, they're basically, you write something, they support a range of languages, so you gave it your Java or your Python or your Node or whatever, you upload it to it, and then you can call it, typically via REST API, or you can call it, they themselves can call themselves directly without going through a REST API. And it is quite fun. It's quite good to use. And it's remarkably cheap. So Amazon's Lambda costs 0.0000002 cents for every 100 milliseconds that you use 128 meg of RAM. Got that? Sounds cheap, right? But cloud cost engineering is turning out to be the hardest thing man has ever done. It is very easy to turn that many zeros, a fraction of a cent, into 10 grand a month. We have done that several times. Because of course you just go, wow, it's that easy, right? So you suddenly go, we have this data feed with 1 million things a second, plug it in and amazing stuff happens. And we've done that lots, and then you suddenly realize, when it gets to that scale, it is quite challenging. But it is on the whole very, very cheap, but of course you're paying based on usage. You're not paying on a server sitting there, or even a container sitting there, at whatever percent capacity it is. You're paying just on your usage. If you have no users that day, you don't pay a thing, right? That is lovely kind of financial model. And one more quote from Mike Wardley: expect to see the whole world being overtaken by serverless by 2025. So what's that, 7 years away? Imagine all the technology, all the code we've written, or the vast majority of it, being serverless within only a few years. I think he's right. That's pretty scary, right? The most popular way that this stuff is done today is kind of triggered based on something, and it's great for that event-driven stuff. So you can have, for example, a file drop in an S3 bucket on Amazon, and have a Lambda automatically pick it up, pass it to Amazon's machine learning stuff, analyze the file for patterns, or if it's an image, you can for what it is, and then do something with it, right? It's great for that on-demand, event-driven bits. And there's loads of examples of that, and it's slowly getting better. Every year, all the cloud providers add new features to make it better. You can run stuff for longer, have more memory. They're building a library of all the stuff ready for you. It's getting better and better. The one that's maybe a bit less mature is that kind of service-based, when you request something. The things that you might, so this could be a web server style behavior, or it could be like an order processing thing. You can do it that way, but you begin to realize there's some limitations with this stuff. It means they've used the word function intentionally. They're relatively small things. And my understanding, I think, at least of all three of the serverless ones, is that they're single-threaded. There's a limit to how long they run. You maybe don't have some of the stuff around you that you would need, in the same way that if you were to build a traditional kind of API-based server application, that you would have all that there. So this is an area that's no doubt going to get bigger if we are to truly be serverless within a small number of years, right? How do you re-architect your stuff so that it makes sense to do big, complicated things at scale in a serverless way? And that's the kind of thing we've been experimenting with a bit, and we've come up with a pattern called the nanoservices pattern. So the nanoservices pattern is the idea of, we've all heard of microservices, right? It's smaller than a microservice, but it's not 1,000 times smaller than a microservice. It is bigger than a function, smaller than a microservice, and it is the kind of ideal thing to run in a serverless world. So what's really interesting about it is it's kind of the ideal size to think about and launch, to test, in isolation. This wonderful world of continuous delivery is all about having the smallest possible changes, right? Continually evolving live, so you don't have the big bang monolithic release. And this lets you go even further, perhaps, than a microservice did. So, for example, if you had an API for processing orders, you might have, like a get order or make order or show order status. You can imagine a REST API with all those different bits. Each one of them in this world might well be its own nanoservice. Does that make sense? So the place order API call would be a separate nanoservice that you could separately develop, test, deploy, roll back, whatever. So they are very small. That means, in turn, you're going to have lots of them. So you're going to have quite good tooling and communication about all the things changing. We're getting to a point now where we are having stuff change every few minutes. Fairly small things, but they are changing every few minutes. So how do you keep track of that? That's one of the challenges. And then, of course, what you do is, just like with microservices, typically you don't just need one microservice, you combine them together. So with this, you're going to have quite a few nanoservices that come together to form a rich system, each independently made and released, but together they do whatever rich, wonderful thing you want them to do. And then that is built on a serverless platform. Make sense? Cool. So, where's this word nanoservice come from? There's a few people talking about it online. Netflix are talking about it, for example. It's not a huge term. It might not be the term that kicks off, but you can think of it generally, just principle. In a serverless world, how do you design stuff so that large teams can work on complex things? Wikipedia doesn't have one, but it does, within the microservices page, have a section on nanoservices, where they comment that a nanoservice is an anti-pattern, where a service is too fine-grained. Oops. Fortunately, this is right. So if you were to make microservices too small, so you have lots of them, then the overhead of maintaining them becomes higher than the benefit. And operationally, the overhead just of communication can be pretty high. If you're doing a kind of classic HTTP REST call, that's hard to get that down to less than tens of milliseconds. If you've got an awful lot of them, that's going to get very expensive. But if you can get around that, if you can have your tooling and your serverless approach so that one nanoservice calling another is nice and quick, and you can handle lots of different ones in production, and the relationship between them being simpler, then maybe it's got something interesting, right? Because you've managed to make that unit of change and understanding even smaller. This is, hopefully the BBC News homepage. A little old now, I think, but this is the most popular page we have. It has tens of millions of hits every day. And so we thought, that would be a great one to give this nanoservice idea a go on. So we did that. And what we did is we go, well, that box there, that can be a nanoservice. And so can that one. And so can that one. And so can that one. And if we scroll down the page, it's the same thing down there. So there are dozens of nanoservices, literally dozens involved in making this page. And what that means is different teams can build different ones. So there's a team that specializes on live events, for example, built that kind of timeline one there, and the more traditional kind of journalistic teams build some of the other ones. And further down, when there are promos to other things, they're made by other teams as well. So we found a way of lots of teams coming together, building this stuff, and they're developing it in isolation, and they're releasing it in isolation. So you haven't even got a point where one team needs to do a big launch of all the different team stuff. You've got lots of teams able to work on their own to kind of bring together what is quite a big, rich page. Another example, the kind of richest page we have is a page we have for covering live events. And it's a kind of clever page that can work out whether it's a sport event, cricket in this case, or is it cricket? Yeah. Or it can do elections or music events or anything. It's kind of a very flexible page. And so there's lots of teams working on this. So when it's in the music mode, it shows you the playlist of who's currently playing and what song they're playing. When it's in the news mode, it might show you the election results and so on. And it's great because each one can work on together on their things. And again, all of those bits made by different teams potentially, each one a nanoservice. So there's things that specialize in this case in cricket data, might be one the video team did that kind of video carousel on the right, and so on. How's it working then? Well, it's really quite straightforward. We haven't used Lambda. We built it on Amazon, we haven't used Lambda. Partly because we did this a few years ago and Lambda wasn't quite so mature, and partly because Lambda does have a habit sometimes of taking a few seconds to invoke, which would have just killed us for making a web page. So what we've basically done is we said, when you want to make one of these, you have to write it in Node, but you just upload the code into a bucket, an S3 bucket. And obviously there's tools to help you do that. And then when a user comes along requesting a web page or an API call, whatever it is they're doing, we simply have some virtual servers, some EC2s that load the code if they haven't already and run it. It's kind of that straightforward. They often need to make calls out to go and fetch whatever data they're getting, the article that the journalist has written or whatever, or the video, but that happens. And we have a massive cache as well because we have a lot of users, and we even have a queue so that if there's a lot of parallelization that needs to happen, as sometimes you can get, that can help as well. And incidentally, Redis, if you don't know it, is the most phenomenal technology. It is so extraordinarily quick and great, not just as a classic cache, but as a queue or as a streaming protocol, all kinds of stuff. Fairly simple, right? I think we will look to move this to Lambda as it gets better. Maybe today it's perhaps in a better state now. But for now, we kind of implemented our own serverless platform, if you like. But it was fairly straightforward to do, and what it's meant is that we have a team looking after that's not too big, but then everyone else is just concentrating on writing whatever logic it is to do whatever they're doing. Let's go back to this one again. So there's a number of boxes there, a number of nanoservices, and it's not just the visual stuff. So this is just talking about web pages, but all the logic going on behind the scenes is also happening as nanoservices. That is the full tree of that particular example. So the yellow ones are the visual ones, making HTML. We use React, if you're interested. The gray ones are the ones then getting the data, providing that kind of view model for it. And the green ones aren't nanoservices, they're the kind of backend. We have all kinds of various different backend APIs. Make sense? Kind of cool, right? Different people can write different ones, release them at different times. Looks neat. That page, that live event page, as I say, does all kinds of different live events. And if you were to add up all the different nanoservices involved in making that page, it looks like this. Which is a bit mad, right? And we're still debating whether or not that's too mad. Because at the end of the day, if we were to have made this another way, microservices or as a monolith, you still need all that logic. So it's not as if we've made stuff we don't need to make. What we've just done is separated it into small bits and then made a not very good diagram to see what's going on. I think we need to work a little bit on our diagramming. If I zoom into a little bit, you might be able to see, has it got a laser? Cool. Sport, cricket batting table, so that fits the kind of one we were looking before, the cricket bits. Pagination for handling that. There's something over here about languages somewhere. Yeah, localization, because this works in different languages for different people. The language specialists have built that bit to kind of adapt it. So it's a bit mad. Look at these lines, like they're crazy. It doesn't work at all as a diagram, but as a process it does work because you've got lots of teams able to kind of work in their own world at their own pace. So each one has its own ecosystem. It has different versions. Versioning is a really key thing, because of course if you're making all those little changes, how do you know what the effect is? And how do you know, if you're going to make a behavioral change, an interface change, you need to do that. So we do semantic versioning. We can have major, minor, point releases so that we can control whether or not the change should automatically get propagated out to everyone, or whether you need to redeploy the nanoservices around it in order to kind of bring on that change. Everything is clearly owned, which is a really important thing in a large organization. There's a concept of static files as well, if you need that. There's a single-click deploy. You've got these things that you can just upload, and they're there. You don't have to redeploy any servers or containers or whatever, because it's just that bucket, if you remember the architecture. They're all connected to each other. We've made some analytics so we can see what's going on, and we've got some of them that are literally called thousands of times a minute. It's really huge numbers on it. Then you've got the concept of who's using you. You've got the test features individually tested automatically as much as possible, and we happen to have written in a node. I think the concept works for any language. Demo. Now we're going to do a demo. Unfortunately, I've only got this. So we're going to Alt-Tab into the website, which I screenshotted earlier, so this might not be the latest news, but this is this morning's news. And as I said, this is one of the examples of it. And this viewable bit, so there is that viewable bit asking the system just for that nanoservice. And that makes use of other nanoservices, as we showed this earlier, to do some of the various bits of it. But you get the idea. It's obviously lost some of the styling and images and so on because it's not part of its bigger page. But you can develop and change that, or you can reuse it. That's now an API call, should you want, or another nanoservice that you could use elsewhere. Beneath that, if we were to look on the page beneath that, there's like a must-see bit. And so again, that's the next one down. You can see it's even more, for some reason, lost at CSS even more now. But there is the lovely baby. And that, again, is something that is individually developed, released as you want it. And you can kind of carry on. So further down the page, the most popular part of the news homepage, BBC News homepage, is the most read bit. Everyone loves that bit, which really annoys the editorial team, who spent ages crafting what should go top of the page, and everyone scrolls down to that bit. But that again, the same idea, right? And behind the scenes, if I go next again, behind the scenes is another nanoservice that's doing the data to power that. So it's that same concept. In this case, it's just returning the data, not the HTML, but it's that same concept. Again, could be made by a same or a different team, or you could have that as an API going to an app, for example, or whatever. These are all these separate things that you can use in all kinds of different ways. And that is a screenshot of part of the GitHub. So unfortunately, it's all closed source, but each one has a space in GitHub, and it can have documentation, different parameters, example. So we now have hundreds of these nanoservices that are these things which you can go and read about, and you can go and use and plug in different ways. So we kind of really made that Lego set of all these things, which is very cool. So how are we doing for time, Kev? Few minutes? Cool, right, we've come towards the end anyway. So we have got these Lego bricks for sharing, and they are easy to understand concepts. We've even had situations where we've had third parties make these nanoservices, and then we brought them in-house. And in the past, when we've had some code made elsewhere and asked an in-house developer team to look after it, there's been a riot. Everyone hates looking after other people's code. But in this, unfortunately, I wasn't able to screenshot it, but these nanoservices typically have at most a few hundred lines of code. So they're really quite approachable. So you can kind of go, okay, I get that. It wouldn't know how I write it, but I get it. And so we've managed to kind of move them between teams, the ownership of them, and got away with it. They should be good value because they're nice and small and highly cacheable and highly reusable. The operational side, you don't have to worry about. If your expertise is in making web pages or data handling or whatever, you can just do it, pass the code over, and not care about the challenges of scaling or security or setting up your servers or whatever. And you have, that's the same idea, separating the concerns between kind of the service running and the logic of it. Deployment is super quick, and ultimately, the whole reason we're doing all of this is to speed up the rate of development and release of our stuff. Challenges, the system we found, because we made our own serverless platform, we've realized it's quite hard to make a serverless platform. If you have one that runs away with itself, takes too long, gobbles up all the memory, that kind of thing, it can hurt others. So you need to be very conservative and sandbox off as much as you can, which means in turn there's going to be some restriction to what it can do. We've had a proliferation. We've got well over 1,000 versions of all of our nanoservices now. It's kind of interesting to work out how to handle that. In general, if we've got multiple versions in use, we don't care because they're just more bits of file hanging around. But there is a kind of a point where that becomes a bit mad. And that you can end up with some interesting spaghetti dependencies. Again, it works, so it's a question of whether that's a problem or not. But as you saw from the diagram, it does get rather big. Reuse isn't a given. We hoped with all these little things, lots of people would use them in different ways. Why reinvent the wheel? But of course, everyone likes reinventing the wheel. And it's not super, super fast. Same argument to the programming language, right? You don't pick Ruby if you want the fastest possible thing. You pick it because it's fast to develop in. And it's the same concept here. If you need something incredibly fast, you wouldn't do this. But for most things, you would. And that in turn can lead to kind of rather inefficient stuff if you don't get it wrong. So you do need great tooling to do it. And if you're interested, we've written a blog post on this on Medium, but so has Netflix. I've written two on what they've made almost exactly the same thing, which we thought was we kind of read it and thought, we can just copy and paste this to our blog post. It's freaky how much some guys in California have made something, such a similar concept. So that's it. Whether you agree with the pattern or not, do consider serverless because it is clearly the future. It is abstracting away all kinds of stuff that is really quite boring. But we think there is an interest in this pattern and it's working rather well for us. And that's it. Thank you.